This is number 6 from 7.5. We're building this parabolic dish. Um, so, we're rotating this parabola around, and our parabola, just this half of it, is going to look like so. But I know it's 10 foot wide, so this goes all the way out to 5, wherever we stop it. And then the top of it is at 1, right? Because it wants to be 1 foot deep, okay, and 10 foot wide. So imagine the other 5 foot is on this side of it, okay? I'm just saving that room to write. Now, a little bit bigger question in here is about this whole surface area thing. So I want you to think about, we're rotating around the y-axis, and so our little rectangle-y type thing, but actually we're going to use more of a trapezoid, okay, where this side is going to be the arc length. Okay? Now, as we rotate that around, we're going to get another one of these little cylinders, right? Okay? Where we have the radius here, and if we unroll that, we get the little rectangle, okay? So the height is going to be the arc length, and this is just the circumference, which is 2 pi times whatever the radius is. In this case, the radius is whatever this x-coordinate is. Okay? So the radius is 2 pi times x. The arc length, if we just think about that one little representative part, it would be the square root of 1 plus whatever that derivative is squared. Okay? So the area of that little slice then that we need to integrate is going to be 2 pi times x times the square root of 1 plus now f of x, the other part that we had to find, we know it's ax squared, and we also know that this top corner up here is at the point 5, 1, right? Because it goes out 5 for that radius, and then just the depth of 1. So we know that's 1 equals a times 25. So a is 1/25. Okay. So our function is 1/25 x squared. So the derivative, 2/25 x, we'll square that, and then we're going to integrate all the way from 0 to 5, because since we're doing it with respect to x, we've got to go all the way from here over to the 5. Okay. Now, simplifying a little bit, I'm going to go ahead and pull that 2 pi out. 0 to 5. That's going to be 1 plus 4 out of 625 x squared dx. And I'm going to do a u substitution here. Okay, so I'm going to let u be 1 plus 4 over 625 x squared. Then du is going to be 8 over 625 x dx. And looking at kind of my matching game here, the x dx is already there, right? So when I make that substitution, we're going to have then 625 over 8 square root of, well, u, right, du. And then we need the new upper and lower bounds, right? So my lower bound, when x is equal to 0, my lower bound is going to be 1. But my upper bound, when x is 5, let's see, 5, my upper bound is going to be 8 over 125. Just keep in mind, right here, I'm just substituting in 5 for, what did I just do? Yeah, substituted into the derivative instead of that. So if I put 5 in there, let's see, 29 over 25. Okay, because we're putting 5 in here, okay, for the x squared. So our integral then is going to go from 1 to 29 over 25. So 625 pi over 4 is the integral of 129 over 25. Okay, the square root of u du. And that's going to be, 2/3 u to the 3/2 evaluated from 1 and 29 over 25. I'm just going to use the calculator to do this. Okay, so let's see. 29 over 25 to the 3/2. And I am coming up with like 81.6, somewhere around there. Oh Lord, I got the right answer. Whew, thank God. Okay, because that was going to be a lot of work otherwise, right? Okay, so there's that one. Now, one other part of the questions we had, and I didn't have enough space here, but it's a good place to address it with this surface area. You know, let me just get a new document so I can get a new page. Heck with it. Maybe. Okay, if I am looking for to find surface area, and I'm thinking about the arc lengths and stuff like that, like we had on the last one, if we have whatever function it is, okay, and we are rotating that about the y-axis, then our little rectangle looks like this. Okay? And the radius, okay, for our disk that we're going to unwind, right, that radius is always just going to be the x-coordinate because it's however far we have to go out. Okay? So that means the circumference, okay, is always going to be 2 pi r. So then the area, when we unroll that, will be 2 pi times the x-coordinate, because that's what r is, times the arc length, which would be this, right? Now, if, on the other hand, we have something and doesn't matter what shape it is, and let's say we're going to rotate it about the x-axis. Okay? If we're rotating about the x-axis, then our little rectangle-y, or really what is a trapezoid, right? It's going to look like that. Okay? So when we roll it around, still, we're thinking about the circumference, because when you unroll that, you get this rectangular shape, well, really trapezoid, right? If you got this here, but it's so small we're thinking about it rectangle, thinking about base times height type stuff. We're still thinking about the circumference, except this time the circumference is the y-coordinate, right? So it would be 2 pi times y times the square root of 1 plus f prime of x squared. Okay? Except if we're doing f prime of x, we want everything in the same thing. So whatever the function is, instead of the y-coordinate, we're just going to use f of x. So then we'll integrate that. So it depends on what axis you're rotating around, depends on what is in this spot. Sometimes it's f of x if your y-coordinate is the radius. If your x-coordinate is the radius, you're always going to have an x here. So I hope that clears that up a little bit.